Hello dear students. So today I will continue the next part of the syllabus in three-phase induction motor is rotating magnetic field and principle of operation of three-phase induction motor. So let me begin with what is rotating magnetic field or RMF. When a three-phase winding is energized from a three-phase supply, a rotating magnetic field is produces. So it means that when you give this three-phase supply to the machine, so the current will flow in each winding and the magnetic field is produced across each winding. So that magnetic field is called rotating magnetic field. Why this magnetic field is rotating? Because its poles do not remain in the fixed position on the stator but go on shifting their positions around the stator. That's why it is called rotating magnetic field. Otherwise, simply we can say it is only magnetic field or magnetic flux. But we can say that the magnitude of this RMF is constant and that too equal to 1.5 times the maximum flux. So this we can prove by taking the three reference equations, that is the flux produced by the R phase Em into sine of omega t reference equation, flux produced by the Y phase Em sine of omega t minus 120, because the phase difference between the Ry, Yb and Br is 120 degree. By substituting this omega t, theta is equal to omega t is equal to different angle 0 degree, 60 degree, 120, 180, 270, 360, so on. So you will get the three equations, pi r, pi y and pi b. Then the sum of pi r, pi y, pi b is equal to the total flux, okay, and the resultant, the total flux, you will get 1.5 into pi m. So the magnitude will be remain same for any different angle. This we can prove from the phasor diagram, okay, 1.5 into pi m. So what is synchronous speed? Synchronous speed means the speed at which the revolving flux rotates is called synchronous speed. Means what I'm saying is, so whenever the three-phase supply is given to the induction motor, the RMF is produces. This is a rotating magnetic field. So rotating means at what speed is rotating? At synchronous speed. Okay, the speed of this flux we are taking as a synchronous speed, the speed at which this flux rotates. Then it depends upon the number of poles and the supply frequency. We can see Ns is equal to 120 F by P, or we can write F is equal to Ns into P by 120. If you take P is equal to 6 pole, F is equal to 50 Hertz, then you will get the Ns is equal to 1000 rpm. So 1000 rpm indicates what? If it is a 6 pole machine, 50 Hz supply is given frequency, then the Ns is 1000 rpm, means the flux is rotating around the stator at 1000 revolutions per minute. For every minute 1000 times it is rotating. That is the meaning of synchronous speed. It is not the speed of the rotor. Okay, it is not the speed of the induction motor, it is just the speed of the flux. Okay, so now we'll discuss the principle of operation of induction motor. When a three-phase stator winding is energized from a three-phase supply, a rotating magnetic field is set up which rotates around the stator at synchronous speed. So we have already discussed earlier, when three-phase supply is given to the machine, so the current will flow in each winding. So in each winding the magnetic field is produces. So that magnetic field is called rotating magnetic field, and the speed of rotation of RMF is calculated with the help of Ns is equal to 120 F by F, N20 F by P, that is the synchronous speed. So this RMF passes, whenever this RMF passes through air gap and cuts by the rotor conductors, so which are at a stationary. It means at this point the magnetic field, the flux produced by the stator, this RMF is rotating. At this point the rotor is stationary. So I will explain this with a simple diagram. Here you can see this is the stator winding and this is the rotor winding, and above is the stator, below is the rotor, and there is an air gap between the stator and rotor. So here the large number of rotor conductors are placed. So the positive sign indicates the EMF is induced in the rotor. So whenever the three-phase AC supply is given to the induction motor, what happens? Then rotating magnetic field RMF is produces. That is a rotating magnetic field. So in which direction is rotating? So let us assume it is a direction in the anti-clockwise direction for this diagram. So if it is rotating in anti-clockwise direction, then whenever this rotating magnetic field passes through air gap, and whenever this flux cuts by the stationary rotor conductors, okay, here we have many conductors. Whenever this magnetic field cuts by the stationary rotor conductors, then an EMF is induces in the rotor according to the electromagnetic induction. So whenever the EMF is induced in the rotor conductor, then because of the short circuited rotor, so the current starts flowing in the rotor. So the current will flow in the rotor conductors. So the current carrying rotor conductors are placed in the magnetic field produced by the stator. So then consequently the mechanical force acts on the rotor conductor. So the sum of the mechanical forces on all the conductors, that produces the torque. So this torque tends to move the rotor in the same direction as that of the direction of the magnetic field. So it means that the motor starts rotating. So remember students, when three-phase AC supply is given to the induction motor, then rotating magnetic field is produces. At this point the rotor is not rotating, means the shaft is not rotating. Whenever this RMF passes through air gap and cuts the rotor conductors, then an EMF is induces in the rotor. So this EMF induced in the rotor means the current will flow in the rotor conductors because of the short circuited rotor. So whenever the current flows in each rotor conductors, then the mechanical force is develops. The sum of mechanical forces of all the rotor conductor pushes the rotor into the same direction. The sum of the mechanical forces of all these conductors produces a torque. That torque tends to rotate this rotor in the same direction as that of the RMF. Means if it is rotating in anti-clockwise direction, the shaft is also rotating in anti-clockwise direction. If it is rotating in clockwise direction, the shaft is also rotating in clockwise direction. In that way, the rotor will be starts rotating in the induction motor. That speed, whatever the shaft is rotating, that speed you can call it as a actual speed, that is N, and Ns is the speed of the rotor flux. Sorry, the speed of the stationary magnetic field, that is a rotating magnetic field. Okay, so this is the working principle of a three-phase induction motor.